All right, continuing with our big idea, objects have attributes such as length, area, perimeter, and volume or capacity that can be measured, and measurements of the same attribute can be used to compare objects. Today we're going to talk about volume and being able to figure out that we can compare two shapes using volume. Now, volume is a little bit different than area and perimeter because it's no longer working with a flat shape. It is now working with a 3D shape. So today we're going to work on figuring out how to find the volume, how much space is inside a 3D shape, and then what kinds of reference for centimeters cubed and meters cubed that you can use to estimate for volume. So let's take a look at this box. How could you find out how much space there is inside this shoebox? Well, when you look at volume, you are trying to determine how many cubes fit into a shape. It might be centimeter cubes, it might be millimeter cubes, which would be really tiny. It might be meter cubes, which would be really large. Each side of those cubes being either centimeters, 1 centimeter for centimeter cubes, 1 millimeter for millimeter cubes, and 1 meter for meter cubes, which makes them quite a bit bigger. When we find volume, we use the length, the width, and the height to determine our volume. Really, what we're finding is the area of the bottom of the box, and then how many layers of that we would have to make our height. So, let's assume my box is 5 would be too small. Let's go 15 centimeters by 10 centimeters by 7 centimeters high. First, I need to find out my bottom layer, which would be the area. So 15 times 10, 10, or length times width. 1 times 15 is 15. We add the 0, so that's 150. I now need to multiply by my height, which is 7, because I've got 7 layers of 150. So I'm multiplying by 7, which is multiplying by my height. 150 times 7, I'll probably have to punch into my calculator. And 150 times 7 is 1,050. And we said this was all centimeters, so it's centimeters and cubed, a little 3, because it's 3D shapes that we're working with and 3D shapes that we're filling this box with as well. So 1,050 centimeters cubed would be the volume of this shoebox. How much space is available inside the box? Now, if we are estimating for volume, we find the volume, of course, by finding out the amount of space inside the object. We can find the volume of a box by filling it with identical items and then counting them. So that's a good way to estimate. The key here is to fill them with the same item. The same item because, again, it's easier to compare and count and compare that amount of space if it is the same item. If I was using a different item, that would not work as well. Okay, so for example, here we have a box of chalk. It holds 144 sticks of chalk, so the volume is about 144 sticks of chalk. The about, remember, is what tells us that it's an estimate. Also, considering the fact that these are circular pieces of chalk, and when you have circular pieces of chalk next to each other, there is going to be some space that isn't going to be filled. So this is more of an estimate, I suppose, than if it were filled with cubes that don't have any spaces between. Here's another estimate. Here we have a box that is filled with sugar cubes. Now, cubes are better because there's no spaces between them. As you can see from the picture and my drawing, there's no spaces between those cubes. So because those cubes are the same the same size, and there is no spaces, this really is the actual volume. Okay, so this would have 80 sugar cubes, so it would have an 80 sugar cube volume. We can't necessarily make that a centimeter or millimeter unit because we don't know how many centimeters or millimeters are in each cube. But that would be no longer an estimate really because it's taking up all of the space within that box. All right, and a centimeter cube is very much like a sugar cube. There's not going to be any spaces between it, which is why it's a good item to use to measure volume with, which is what we use. We will consider the cube to be a centimeter cube if all of these lengths are 1 centimeter. So this then becomes a centimeter cube. If you think of our little yellow squares that we have in the classroom for place value, those little yellow ones that are for the smallest little squares, those are centimeter cubes. So a centimeter cube is about that size, so you have a visual of what it looks like. Here we have a box. It holds 4 rows, so our width of 4, of 6 cubes, our length of 6, and it only has 1 height of those. So volume we know is length times width times height. So 4 times 6 times 1, because there's only 1 layer. 4 times 6 is 24. 24 times 1 is still 24. It's 24 centimeter cubed. Okay, because there's 1 layer. Sometimes we have irregular shapes. Okay, an irregular shape is one that is not a rectangular prism. It is not a nice rectangle of layers. In that case, we actually have to count the number of cubes. Now, this is where it's a little tricky because you have to imagine some of the cubes that are behind. So here we have 1 row of 4, but we know back here we can see there's another row of 4. So 2 rows of 4 and 1 row of 3. Well, 4 plus 4 is 8 plus 3, that makes it 11 centimeters cubed. That's what we do when we have an irregular shape. We actually have to count the number of cubes. All right, here we have another box or a rectangular prism. We have the length, the width, and it tells us that there's 2 layers. So if there's 2 layers, that means 2 is our height. We have 4 as our length, and we have 2 as our width. The length we said was 4, our width we said was 2, and our height we said was 2. Now we know for volume it is length times width times height. So to figure this out, we're going to have to multiply these. 4 times 2 is 8, so 8 in 1 layer. 2 layers of 8 is 16, so it would be 16 centimeters cubed. All right, now you get to practice. So you're going to press pause, you're going to do the work on your paper, and then you're going to compare your answers afterwards. Go ahead, press pause and do that now. All right, let's take a look. For the first one, A, volume we know is length times width times height. And again, it doesn't really matter if you know the formula, but you will need to know it for grade 6, and kind of helps you remember the difference between volume, area, and perimeter. So I'm going to keep doing that part for you. If you'd like to do it, go ahead. If you don't find that helpful, you don't have to at this point, but you will have to in grade 6. All right. So in this case, it's 2 times 2 times 2 because we have 2 as our length, 2 as our width, and 2 as our height. Now, in reality, it doesn't matter if you switch those around because commutative property, remember, the order in which you multiply numbers doesn't make a difference. So if you're not sure which one is the length, which one is the height, which one is the width, it doesn't really matter. In this case, it doesn't matter at all because they're exactly the same number. 2 times 2 is 4. 4 times 2 is 8. So 8 centimeters cubed for A. For B, again, volume equals length times width times height. So then our volume is going to be 5. Actually, if we were talking about the proper length, should be 4. times 3 times 5. But again, it does not actually matter what order you multiply them in, thanks to the commutative property. 4 times 3 is 12. 12 times 5. Well, we can break this apart. 10 times 5 is 50. 2 times 5 is 10. 50 plus 10 is 60. So 60 meters cubed. Remember to look at the units. This is meters now, no longer centimeters. And let's take a look at our last one. C. Again, volume equals length times width times height. Our length is 6, our width is 3, our height is 2, doesn't matter what order. 6 times 3 is 18, 18 times 2. Well, 8 times 2 is 16, 2 times 10 is 20, 20 plus 16 is 36. So it's 36 meters cubed. All right, that's our practice with volume. Now, not only do you need to be able to find the volume of a shape, but you also need to be able to build a rectangular prism with a given volume. So if I gave you 11 centimeter cubes, you needed to make whatever rectangular prisms you can with it. Well, with 11 cubes, there's not much else you can do but one big long row of 11, which would have 11 centimeters cubed. However, if you had 12 centimeter cubes, well, there's a lot of ways we can find to multiply to equal 12, okay? We could have, well, we know 3 times 4 is 12, and we could have one layer of that. So 3 rows of 4, one layer is 12. Perfect, that works. What else could we do? Well, let's see. 2 times 3 is 6. 6 times 2 is 12. 2 by 3 is our first layer, and we have 2 layers of that. That works. What else could we do? 2 times 6 is 12, and we could have one layer of that. Oops, times one layer of it. 6 times 2, we've got one layer. So that's 12 as well. So we can do a number of different things. What we could do even is we could say, okay, 12 divided by something. Let's try it. 12 divided by 3. So 3 is one of my lengths. Well, 12 divided by 3 is 4. So I've got 4 left. Well, what could I make multiply something times something that's going to equal that 4? Well, 2 times 2 is 4. So that works. And really, that is the same as this here that we already have. So that's 2 different ways that we can multiply to find a given volume. Now it's your turn. You're going to create a rectangular prism with a volume of 32 centimeters cubed. Go ahead and press pause and try that. When you're done, compare to your group members. What kinds of different rectangular prisms were they able to come up with? What did you come up with? Did any of you have the same one? Were there any different ones? Go ahead and press pause and create your own rectangular prism that has 32 centimeters cubed. 32 cubes, really. If you need to, you are welcome to use the cubes that are in the classroom. If possible, you want to get to the point where you don't need the cubes, but they're a great place to start. So feel free to go grab those cubes to try it now. All right, well, let's take a look at some of our possibilities. So we want a volume that's going to be 32. So we need something times something times something that's going to equal 32. Well, let's see what we can have for possibilities. Let's try something. Let's try 32 divided by 2. What is 32 divided by 2? Well, that's 16. So I could have 2 be one of mine. And then something times something, that's 16. Maybe 4 times 4. Or maybe 2 times 8. Do those both equal 32? Well, let's check. 2 times 4 is 8. 8 times 4 is 32. Yep, that works. 2 times 2 is 4. 4 times 8 is 32. Yep, that works. What else could we do? We could even go 2 times 1 times 16. We could have one row of, or one layer of 16 rows. 2 rows of 16, I guess is what that would look like. 2 rows of 16 and only one layer. 32. What else could I divide 32 by as my first step? I can't divide it by 3. I could divide it by 4. Okay, let's see what else I could come up with. Sorry. Let's try a different color for the other one here that I'm going to try. 32 divided by 4 is 8. So I know 4 is going to be one of them, and I need something times something that's going to equal 8. Well, what times what is 8? Well, 2 times 4. I could also have 4 and then something times something that is 8. 1 and 8. Is there anything else that could work? I think that's about it. That's all that's coming to my mind at the moment. But as you see, there's lots of different possibilities. All you really need are 3 numbers that multiply together to equal 32. All right, now you are on to your concept practice, which includes finding the volume and creating a rectangular prism that has a certain volume. Page 140, numbers 6 and 10, and page 143, numbers 1 and 2. As always, remember to show your work. You're more than welcome to use a calculator, but again, that work needs to be there. So if you're typing in 3 times 8 times 2, I want to see that. And then, of course, your answer, 3 times 8 is 24, plus 2 is 48. That's the work that I want to see. Also, make sure that you're always showing your units, whatever the units happen to be, and they need to be cubed with that little 3 to show that it's a 3-dimensional cube that we are using to fill that particular shape. And of course, as always, if you have questions along the way, please remember to ask. And here you have some open questions for volume if you are finished to try either one, whichever you prefer. And then lastly, here is your exit slip for perimeter, area, and volume. As always, show your work. You will need to do your work on grid paper. There is not enough room to do that here.